Imagine a celestial object so ancient that it seems older than the universe itself, or a region of space so empty and vast that it appears to repel matter, as if defying gravity itself. What about a star system that behaves like a cosmic sprinkler, shooting out jets of material in ways we've never seen before? These are not the products of science fiction. They are real phenomena lurking in the depths of the cosmos. There are black holes that should have starved long ago, yet continue to consume matter at an insatiable rate. Planets that shimmer with elements so rare they seem more like jewels than celestial bodies. Stars that pulse and flicker in inexplicable ways, hinting at forces beyond our comprehension. And in the vast nothingness of space, there are structures so bizarre that even the most advanced telescopes struggle to explain them. In this journey through the cosmos, we will uncover 10 of the strangest, most enigmatic objects ever discovered. Some defy our understanding of gravity, while others rewrite the rules of stellar evolution. Some are hidden within galaxies close to home, while others reside at the very edge of the observable universe. Prepare to venture into the unknown, where reality bends, time distorts, and the impossible becomes possible. Because out there, among the endless stars, the strangest objects in the universe are waiting to be discovered. The universe is filled with mysteries, but some objects stretch the limits of what we thought was possible. Imagine an object so powerful that it outshines entire galaxies, a cosmic beacon burning with the energy of 500 trillion suns. But this isn't just any quasar. This is something far more extreme. A cosmic enigma that defies everything we know about the early universe. It shouldn't even exist, at least not in the way we understand. And yet, it does. The name of this system, APM08279 plus 5255. Looking at it is like peering into the past. The light we see today has been traveling for over 12 billion years, meaning we are witnessing it as it was when the universe was just 1.6 billion years old. The problem? Its central object is estimated to be a staggering 20 billion times the mass of the Sun, an impossible number for something so young. Nothing in standard cosmology explains how something of this size could have formed so quickly after the Big Bang. Even the most optimistic models suggest that black holes of this scale should have taken several billion years to grow, not a fraction of that time. To fuel such an insatiable cosmic monster, it must be devouring matter at a mind-boggling rate. Observations reveal that its accretion disk, an inferno of swirling gas spiraling inward, releases more energy per second than hundreds of Milky Ways combined. The forces at work here are beyond comprehension, producing X-ray winds, moving at 40% the speed of light. This means that the material being ejected is traveling at nearly 120,000 kilometers per second, an extreme velocity that tears apart anything caught in its path. But what truly sets this system apart is what astronomers found lurking nearby, a discovery that shattered assumptions about cosmic reservoirs. Incredibly, 140 trillion times the amount of water found in Earth's oceans has been detected surrounding this quasar. This is, without exaggeration, the largest and most distant reservoir of water ever found in the universe. And this isn't some frozen wasteland. This water exists in the form of hot vapor, mingling with the searing radiation pouring from the central region. The sheer scale of it is staggering. If this water were collected into a single, massive ocean, it would stretch for light years. Water, one of the essential ingredients for life as we know it, is typically associated with the formation of planets and atmospheres. But here, at the edge of the observable universe, it's found in a place where no life could ever exist. The temperatures in this environment reach 53 degrees Celsius, yet the surrounding radiation keeps the water in vapor form, suspended in one of the most violent regions of the cosmos. This quasar also exhibits another strange behavior, one that defies the way we understand black hole physics. Normally, the surrounding accretion disk is expected to follow a predictable pattern, with light emissions decreasing as matter is pulled inward. However, observations suggest a bizarre cyclic variation in brightness that doesn't match any known models. It fluctuates unpredictably, dimming and brightening in a way that suggests something far more complex is happening deep within its core. Some theories propose that a secondary object, perhaps a second supermassive black hole, is lurking within this system, locked in an ancient gravitational battle. If true, this would mean the system is undergoing a process called gravitational lensing amplification, where the warping of space-time itself causes light to be bent and magnified in a way that creates an illusion of variability. But this remains speculative. What's clear is that this is no ordinary quasar. It is something far more chaotic, something that forces us to reconsider how the earliest galaxies and their extreme objects evolved. And then there's another puzzle. It's redshift. With a redshift of 3.91, this object appears much closer to us than it actually is, due to the stretching of light as the universe expands. This makes it one of the most distant, yet highly visible, objects ever recorded. Normally, objects this far away should be incredibly faint. Instead, it is one of the brightest quasars in the known universe. This raises another question. Could there be many more of these hyper-luminous objects hidden in the early cosmos, waiting to be discovered? If so, our current models of cosmic evolution could be missing a fundamental piece of the puzzle. One of the most dramatic aspects of this system is its massive outflows of high-energy particles. Unlike most quasars, where material is primarily pulled inward, here we see jets and winds blasting outward in colossal streams. These outflows are so powerful that they are likely reshaping entire regions of intergalactic space, preventing future star formation in nearby galaxies. In a way, this system is not just a devourer of matter, but also a destroyer, sterilizing vast areas of the cosmos around it. This kind of extreme activity suggests that the object may be in a transition state, shifting from an early cosmic era into something entirely new. Could it eventually stabilize into a more ordinary galaxy, or will it continue its chaotic existence indefinitely? No one knows. What's certain is that it represents a paradox, an impossibly massive, impossibly bright system existing at a time when the universe should have been too young for such a thing to exist. Even with all we've discovered, many questions remain. Could this system be evidence of a fundamentally different process of galactic evolution? Did it form from a direct collapse mechanism that bypassed standard growth stages? Or is there something else, something even more exotic, fueling this cosmic titan? Whatever the answer, this remains one of the most bizarre and mind-bending objects ever discovered. A quasar so luminous, so powerful, and so impossibly ancient that it forces us to rethink the very limits of the universe itself. The universe hides many secrets, but some are so strange that they challenge our very understanding of space. Deep in the southern sky, in the constellation of Circinus, lies an object that has perplexed astronomers for decades. It is known as Circinus X1, a binary system unlike any other we've observed. At first glance, it may seem like just another X-ray source, but when we look closer, something extraordinary is happening here. It behaves as if it is alive, twisting and reshaping itself in ways that defy expectations. Its jets move in a way never seen before, like a cosmic sprinkler, spraying out material in shifting, unpredictable patterns. What could be causing this? And why does this system act so differently from others of its kind? To understand this mystery, we must first unravel the nature of Circinus X1 itself. This is not just a single star. It is a binary system, a deadly partnership between a neutron star and a much larger companion. The neutron star, an ultra-dense remnant of a once massive sun, has an immense gravitational pull, strong enough to rip matter away from its neighbor. As this stolen material spirals inward, it heats up, creating an extreme X-ray glow that has made this system one of the brightest in our galaxy. But there is more to this than just brightness. The system has shown some of the fastest outflows of material ever recorded, plasma moving at speeds close to the speed of light, creating shock waves that ripple through space. The most bizarre feature of Circinus X1 is its sprinkler-like jets. Most black holes and neutron stars that form jets produce steady, predictable streams of plasma. But here, the jets twist and change direction as if something unseen is controlling them. Observations from the Meerkat radio telescope in South Africa have revealed that these jets behave unlike anything we've ever recorded before. Instead of streaming outward in straight lines, they spiral and fan out, similar to the way a rotating garden sprinkler sprays water. This is due to the complex gravitational interactions between the neutron star, its accretion disk, and the intense magnetic fields threading through the system. But the mystery doesn't end there. Circinus X1 is one of the youngest X-ray binaries ever discovered. Unlike most neutron stars, which are ancient remnants of long-dead suns, this one is only a few thousand years old. It is still surrounded by the remains of the supernova explosion that created it. This means that the entire system is evolving in ways we have never witnessed before. The neutron star is not just pulling in matter, it is actively reshaping the space around it. And the effects of this are visible on a scale far larger than the system itself. As its high-speed jets slam into interstellar gas, they create powerful termination shocks, regions where the material abruptly slows down and releases enormous amounts of energy. These shocks had never been observed before in an X-ray binary system, making Circinus X1 a cosmic laboratory unlike any other. Studying these shocks allows astronomers to understand how neutron stars interact with their environments, knowledge that could help explain much larger cosmic phenomena, from quasars to entire galaxies. But perhaps the most unsettling aspect of this system is its orbit. Unlike most binary systems, where the objects follow a stable circular path, the neutron star in Circinus X1 moves in a highly elongated elliptical orbit. This means that its distance from its companion varies dramatically over time, causing unpredictable fluctuations in energy output. Sometimes, the system brightens dramatically as the neutron star pulls in more material and erupts in powerful outbursts. At other times, it dims, appearing almost dormant. This variability has made it one of the most unpredictable objects in the universe, confounding astronomers for years. Adding to the enigma is the system's extreme X-ray variability. It has been observed at brightness levels that defy explanation, only to suddenly fade away, as if something were blocking its emissions. The source of this irregular behavior is still unknown, but some scientists believe it may be due to an unusually dense cloud of material surrounding the system, possibly remnants from the original supernova explosion. Another mystery lies in the fact that this system is moving through space at an incredible velocity. It is one of the fastest moving X-ray binaries ever found, racing through our galaxy at over 1 million kilometers per hour. This suggests that when the original star exploded in a supernova, it imparted an enormous kick to the neutron star, flinging it through space at breakneck speeds. This motion affects how we observe it, making it even harder to pin down its true nature. What's even more intriguing is that Circinus X1 does not behave like a typical neutron star at all. Some models suggest that it may be on the verge of collapsing into something even stranger, perhaps even forming a quark star, an object made of the most exotic form of matter known to physics. If this were true, it would be one of the most important discoveries in astrophysics, giving us a glimpse of a state of matter that has only been theorized until now. Every new observation of this system seems to raise more questions than it answers. The Meerkat radio telescope has continued to monitor its strange behavior, capturing weekly updates on the evolution of its jets. Each time, the picture becomes more complicated. But what is clear is that Circinus X1 is unlike anything else we have ever found. It challenges our understanding of how neutron stars form, how they interact with their surroundings, and how they evolve over time. Despite being studied for over half a century, it remains an open mystery. We still don't know how long its strange jets will last, or if they will settle into a more stable pattern. We don't know if the neutron star at its heart will collapse into something even more extreme. And we don't know how many more surprises this system has in store for us. Circinus X1 is a reminder that even in the modern age of astronomy, when we have telescopes powerful enough to peer into the edges of the universe, there are still objects in our own galaxy that continue to defy explanation. It stands as a symbol of the unknown, a celestial puzzle that may take decades or even centuries to fully understand. But as long as it remains in our sights, it will continue to challenge our knowledge of the cosmos, whispering secrets that only time and science will one day uncover. Nearly 1 billion light-years across. A vast, empty void in space where almost nothing exists. The Eridanus Supervoid is one of the largest known cosmic structures, yet its sheer size is not the strangest thing about it. It is linked to an unexplained anomaly in the universe, the cold spot in the cosmic microwave background, a chilling remnant of the Big Bang. This region of space is colder than it should be, defying expectations set by standard cosmology. Scientists have searched for explanations, dark energy, quantum fluctuations, and even the radical idea that this void might be an imprint left by a collision with another universe. But so far, no answer fully explains the bizarre nature of the Eridanus Supervoid. To understand the significance of this mystery, we need to delve into what cosmic voids are and why this one is so unusual. The large-scale structure of the universe is like a web, filaments of galaxies stretching across space, forming clusters and superclusters, while enormous dark voids exist between them. These voids are not completely empty, but they have far fewer galaxies than other regions. The universe's expansion is more pronounced inside these voids because they have less gravitational pull holding them together. Most cosmic voids are tens or hundreds of millions of light-years wide, but the Eridanus Supervoid is different. At nearly 1 billion light-years in diameter, it is one of the largest ever detected. The first hints of this supervoid's existence came from an even stranger discovery, the cold spot in the cosmic microwave background. The CMB is the oldest light in the universe, a faint glow left over from the Big Bang, spread across the cosmos as a nearly uniform background of microwave radiation. But when astronomers studied the CMB, they found something unusual in the Eridanus constellation, a large region significantly colder than expected. The temperature difference was small, just a few microkelvins, but it was large enough to be statistically significant. According to standard cosmology, the fluctuations in the CMB should follow a random pattern, yet the cold spot stood out as a clear anomaly. Could the Eridanus Supervoid be responsible for this chilling effect? One possible explanation involves the integrated sex-wolf effect, a phenomenon that occurs due to dark energy. When light from the CMB passes through a cosmic void, the expansion of space inside the void can cause the photons to lose energy, slightly lowering their temperature. If the Eridanus Supervoid is as large and deep as estimated, it could have had enough of an effect to create the cold spot. However, there is a problem. Cosmological models suggest that even a void of this size should not be able to account for the full magnitude of the temperature drop. This leads to more exotic theories. One possibility is that the cold spot is a relic of an early quantum fluctuation in the fabric of space-time itself, a remnant from the chaotic moments after the Big Bang. Another, even more speculative idea is that the cold spot and the Eridanus Supervoid are evidence of something far more profound, a collision between our universe and another. The multiverse hypothesis suggests that our universe might be just one bubble in a vast cosmic sea of parallel universes. If another universe once existed close to ours, a collision between the two could have left an imprint on the structure of space-time, Some cosmologists argue that the cold spot could be the aftermath of such a collision, a scar from an event that happened in the early universe. The Eridanus Supervoid, in this interpretation, might not be a simple random void, but a region where the physics of space-time itself was altered. Of course, these ideas are highly speculative, and many physicists remain skeptical. The standard explanation, an unusually large void coinciding with a cold spot, is still the leading theory. However, even this presents challenges to our understanding of cosmic evolution. The existence of such a massive void raises questions about how the large-scale structure of the universe formed. If cosmic voids are simply the result of normal density variations in the early universe, then an object as vast as the Eridanus Supervoid should be incredibly rare. Some models suggest that voids of this scale should almost never form, and yet here it is, leaving astronomers with more questions than answers. Future observations may shed more light on this enigma. Advanced telescopes like the Euclid Space Telescope, designed to map dark energy and the large-scale structure of the universe, could provide more details about the nature of the Eridanus Supervoid. The upcoming Vera C. Rubin Observatory will survey the sky with unprecedented depth, potentially identifying more structures like it. If similar voids are found, it could help scientists determine whether this is a rare coincidence or part of a larger, unexplored cosmic pattern. For now, the Eridanus Supervoid remains a mystery. Is it simply an extreme example of cosmic evolution, a vast region where galaxies failed to form? Or is it something far stranger, a remnant of an ancient cosmic event, a clue to new physics, or even a sign of the multiverse? The answers may still be far away, but one thing is certain: this void in space is far more than just empty darkness. It is a question waiting to be answered, a puzzle written across the fabric of the universe itself. An object which moves faster than almost any star we've ever seen. A burned-out remnant, rocketing through the galaxy at such unimaginable speed that nothing can stop it. This is LP 4365, a white dwarf that should have been completely destroyed, but instead it survived a cosmic explosion and was flung across the Milky Way like a bullet fired from an invisible gun. Stars aren't supposed to behave this way. They live, they burn, and when they die, they collapse into black holes, neutron stars, or white dwarfs. But LP 4365 breaks those rules. It is moving at over 850 kilometers per second, fast enough to one day escape the gravitational pull of our entire galaxy. Something happened to this star, something that should have been the end of its existence, but somehow wasn't. White dwarfs are the dead cores of stars like our Sun, left behind when they exhaust their nuclear fuel. Normally, a white dwarf remains stable unless it accumulates too much mass, at which point it explodes in a type Ia supernova, an event so powerful that it usually leaves behind no trace of the original star. And yet, LP 4365 exists. So what happened? The answer is stranger than anyone expected. Astronomers now believe that LP 4365 was once part of a binary system, orbiting another white dwarf in an ever-tightening spiral. Over time, its companions siphoned material away from it, growing larger until something catastrophic occurred. The second white dwarf reached a critical mass and began a nuclear detonation, a runaway reaction that should have destroyed both stars in an instant. But somehow, the explosion was incomplete. Instead of obliterating everything, it triggered a failed supernova, a partial detonation that tore apart one star but sent the other one flying. That surviving fragment is what we now call LP 4365. But that isn't the strangest part. Scientists have studied its composition, and it's unlike any other white dwarf we've ever seen. LP 4365 isn't made of the usual elements, carbon and hydrogen. Instead, it's rich in oxygen, neon, and magnesium, the byproducts of a nuclear reaction gone wrong. It is a star made of supernova ashes, blasted apart, but never fully destroyed. This unusual mix of elements is a clue to what really happened. Some researchers believe that LP 4365's companion ignited a thermonuclear explosion, but instead of consuming both stars, it caused a partial detonation, a scenario that wasn't even considered possible until now. This fits with a new supernova model known as D6, the dynamically driven double-degenerate double detonation model. A mouthful, but what it really means is simple. Sometimes supernova don't fully explode. Sometimes they leave behind pieces, fragments of what once was, flung across space like cosmic shrapnel. LP 4365 is one such fragment. A surviving piece of a cosmic disaster, racing through the void at impossible speeds. But if this theory is correct, it raises another disturbing question. Where is its companion? If the supernova failed to fully destroy LP 4365, does that mean its twin also survived in some form? Could there be another impossibly fast white dwarf out there, hidden among the stars? Another survivor of a stellar explosion that never completed its destruction? So far, astronomers have found no sign of the missing star. It could have been vaporized in the explosion. Or, just as likely, it could be out there somewhere, drifting unseen, a second ghost of a supernova that never quite happened. The discovery of LP 4365 has forced scientists to rethink what we know about how stars die. White dwarfs were once thought to follow strict rules, grow too heavy, and they explode. But this discovery proves that the process is far more chaotic and unpredictable than we ever imagined. If LP 4365 could survive a partial supernova, how many other fragments might be out there, speeding through the galaxy, remnants of explosions that should have erased them? Future observations may provide answers. Scientists are now looking for more runaway white dwarfs, hoping to understand just how common these failed supernovae really are. If we can find more stars like LP 4365, it might confirm that this isn't just a one-time anomaly, but rather a hidden phenomenon in our universe, an unseen force shaping the evolution of galaxies. Galaxies are supposed to follow predictable patterns. Their structures, spirals, ellipticals, irregulars, are well studied. Their central supermassive black holes shape their evolution, bending space, consuming matter and unleashing colossal jets of energy. But then, astronomers discovered something they couldn't explain. A handful of galaxies exist where these jets don't follow the expected twin-lobed pattern. Instead, they form a perfect X shape, stretching hundreds of thousands of light years across the cosmos. These structures defy conventional understanding. Why would a black hole eject matter in two completely different directions? What forces could be at play here? And most importantly, are these rare objects revealing something fundamental about the universe that we have yet to understand? At first, these galaxies seemed like an anomaly, mere glitches in astronomical observations. But then, more were found. They weren't mistakes. They were real. In a normal radio galaxy, the supermassive black hole at its core launches two narrow, high-energy jets of plasma outward, perpendicular to the galactic disk. This is expected. But in X-shaped galaxies, something bizarre happens. Instead of two jets, there are four. Two prominent jets extend outward in the usual direction, but another pair stretches out at a completely different angle, forming a massive cosmic. One of the most famous examples of this strange phenomenon is NGC 326, an elliptical galaxy over 200 million light-years away. Its structure clearly exhibits this impossible X pattern, as if its black hole has suddenly decided to redirect its energy flow. But how? What mechanism could possibly explain this eerie, symmetric shape? For years, astronomers debated the cause. Was it an illusion? A trick of perspective? No, these structures were real, and they needed an explanation. The first major theory suggested that these galaxies underwent a dramatic black hole merger. Imagine two supermassive black holes spiraling toward each other, colliding and merging into a single monstrous entity. In the process, their combined gravitational fields shift the orientation of the jets, twisting and redirecting them over millions of years. Could this be the answer? Some evidence supports this idea. When galaxies collide, their central black holes are destined to merge. If each black hole had jets before merging, the new system could inherit both, creating the illusion of an X. But there's a problem. Some X-shaped galaxies show no signs of recent mergers. Their structure should have been disturbed by such a violent event, yet they appear undisturbed. Could something else be at work? A second hypothesis emerged: backflow of plasma. In this scenario, the main jets of the black hole push outward into intergalactic space, but some of that high-energy material curves back due to pressure differences. The result? The returning plasma forms ghostly secondary lobes, giving the appearance of an X. If this were true, then the secondary arms of the X wouldn't be entirely independent jets. They'd be remnants of the original energy flow, bending back in unexpected ways. Observations suggest that this could be happening in some cases, but not all. Some X-shaped galaxies have distinct, powerful secondary jets, too structured to be explained by simple plasma backflow. If those arms were just old, dying plasma, they should appear faded and diffuse. Instead, they appear sharp, defined, and energetic. Then came a third idea: a sudden black hole spin flip. What if the central black hole's spin direction suddenly shifted? If a black hole's rotational axis changes, the direction of its jets would change too. This could happen if the black hole accreted a massive amount of material from a different angle, or if a nearby companion exerted extreme gravitational forces. The result? The older jets would linger in their original direction, while the new jets would emerge at a different angle, creating the X-shaped structure. This explanation is compelling. Some X-shaped galaxies exhibit signs of a sudden jet reorientation, suggesting a violent event changed the spin of their central black hole. But the problem remains: what kind of force is strong enough to flip a supermassive black hole's axis? Could there be unknown interactions at play, hidden forces operating at a cosmic scale that we don't yet understand? The deeper astronomers looked, the more the mystery grew. X-shaped galaxies are not as rare as once thought. As radio telescopes improved, more of them were detected, lurking across the universe. Perhaps this is not an anomaly, but a normal stage in galactic evolution that we've only just begun to recognize. There's another question. If these X structures are formed by spin changes, mergers, or plasma backflow, why do they appear so precisely symmetrical? Nature rarely produces perfect geometric shapes without an underlying law. What if something more fundamental is at work? Some hidden mechanism that governs how black holes evolve over time? The discovery of X-shaped galaxies forces us to rethink black hole dynamics. The traditional model assumes that jets remain stable over millions of years, only slowly shifting due to external forces. But these galaxies challenge that assumption. They suggest that jets can be redirected suddenly and dramatically, reshaping their host galaxies in the process. If that's true, it could mean that the behavior of black holes is far less predictable than we thought. Perhaps this discovery is a clue to something bigger, something missing from our understanding of how black holes interact with their environments. Could these jets be revealing hidden forces, invisible cosmic influences that shape galaxies in ways we've yet to comprehend? Could the laws governing black holes be incomplete, hinting at exotic physics that extend beyond general relativity? Even now, no single theory fully explains X-shaped galaxies. They remain a cosmic enigma, one that defies easy answers. Deep in the cosmos, in a distant galaxy known as LID 568, a monstrous black hole is consuming matter at a rate that defies the fundamental laws of physics. It is not just feeding, it is devouring everything around it, growing so fast that it should have been impossible. By all known rules, a black hole can only grow at a controlled rate, limited by the forces balancing its immense gravity. Yet, this one doesn't seem to care. It is overfeeding, an anomaly so extreme that scientists are struggling to explain it. A black hole can only consume matter up to a certain limit before the sheer force of radiation should push back, preventing further growth. This limit is called the Eddington limit, a cosmic threshold that acts as a natural brake. If too much material falls in too quickly, the outward pressure of radiation should stop the process, regulating the black hole's expansion. But in LID 568, that limit is being violated in the most dramatic way possible. Something has caused an unstoppable cascade of infalling material, triggering a runaway feeding frenzy. Observations show that the radiation levels are far beyond what should be possible, indicating an accretion disk burning so hot and so bright that it threatens to outshine entire galaxies. This should be tearing the system apart, but instead, the black hole continues to gorge itself. One possibility is that a catastrophic galactic collision has sent an enormous wave of gas directly into the black hole's gravitational well. When galaxies collide, their dense central regions can funnel material toward their supermassive black holes, triggering intense feeding events. But even in the most extreme scenarios, the process should still follow a predictable limit. Yet this one doesn't. Another theory suggests that the black hole may be in a hyperaccretion state, where matter is falling in so rapidly that it warps the surrounding space in ways we don't yet understand. This could be allowing it to bypass the normal restrictions, consuming material at a rate never before seen. If true, this would mean our understanding of how black holes evolve needs to be rewritten. There is also the possibility of an extremely dense fuel source feeding the black hole. Instead of the usual mix of gas and dust, what if it is consuming neutron stars, white dwarfs, or even entire planets at a rapid pace? Such high-energy collisions could explain the extraordinary radiation output and violent fluctuations in its brightness. Then there's a more unsettling possibility. Something unknown is at play. Some astrophysicists believe that extreme black holes like this one could be connected to physics beyond the standard model. Could this be evidence of exotic forms of matter? A new type of cosmic engine we haven't yet discovered? Or is it simply an overlooked loophole in the laws of accretion? The energy being released is so intense that it is sending shockwaves across its galaxy, altering star formation, ripping apart nearby systems, and reshaping its cosmic environment. The powerful jets ejected from this black hole extend thousands of light years, cutting through the surrounding gas like cosmic blades. These jets are moving so fast that they are approaching the speed of light, generating powerful magnetic fields and heating up intergalactic gas to temperatures hotter than the core of most stars. If this black hole continues at its current rate, it could reach an unprecedented mass in an incredibly short time scale, becoming one of the most massive objects ever observed. Supermassive black holes usually take billions of years to grow, but this one appears to be evolving on a much shorter timeline. But what happens when a black hole breaks all known limits? Could it trigger something catastrophic? If the Eddington limit no longer applies, could this black hole collapse into something else entirely? Some theoretical models suggest that beyond a certain point, a black hole might transition into a new state of matter, something we can't yet define. Others predict that an overfeeding black hole might violently expel much of its mass in an event more powerful than any supernova, disrupting its host galaxy in the process. There's also the possibility that this black hole will eventually choke on its own excess, releasing a burst of radiation so extreme that it momentarily dims before resuming a more controlled feeding process. This has been observed in some quasars, where the central black hole experiences episodes of extreme brightness, followed by sudden drops in activity. The biggest question of all is whether LID 568 is unique, or if there are more of these overfeeding black holes lurking in the universe. If we have found one, how many others might be out there, quietly defying the laws of physics? And if they exist, Could they be signs of a hidden process in black hole evolution, one we have yet to uncover? For now, the mystery remains unsolved. But one thing is certain: somewhere, in the depths of space, a black hole is eating faster than it should. And whatever happens next could change our understanding of the universe forever. A star that defies expectations. One of the largest apparent diameters in the night sky, yet it is just a fraction of the size of the true behemoths that populate the universe. Located around 200 light-years away, this enigmatic red giant pulses with a slow, rhythmic variability, its surface shifting and expanding in ways that make it a cosmic enigma. Scientists have been watching it, studying its patterns, trying to understand why this relatively small star appears so immense when viewed from Earth. Eridanus is classified as a mirror-type variable star, meaning its brightness fluctuates over time. But its pulsations are unlike those of most variable stars, gradual, almost hypnotic, as if the star itself is breathing. With a diameter nearly 370 times that of the Sun, it seems paradoxically vast and yet fragile, its outer layers barely held together by the weakening grip of gravity. The low surface gravity allows massive convection cells to form, making its surface appear turbulent and ever-changing. But that's just the beginning of its mysteries. The most peculiar aspect of Eridanus is its sheer apparent size in the sky. It is the second largest star in terms of angular diameter, only surpassed by the red supergiant Betelgeuse. However, while Betelgeuse is a true colossus, many hundreds of times the Sun's mass, Eridanus is much closer and deceptively small in mass by comparison. This creates a puzzling contradiction. Why does such a relatively modest red giant dominate our view so significantly? One answer lies in its extended atmosphere. Unlike most stars, Eridanus possesses an incredibly diffuse outer envelope that stretches out far beyond its core. This haze of gas scatters light, making the star appear even larger than it truly is. Scientists believe that this may be a sign of an imminent transformation, the slow death of a star approaching the end of its evolutionary cycle. A star in its late stages will begin to shed its outer layers, forming a circumstellar shell of gas and dust. This is a prelude to its ultimate fate. Within a few 100,000 years, Eridanus will likely cast off its envelope completely, leaving behind a brilliant planetary nebula and a dense, smoldering white dwarf at its core. But for now, it remains in a delicate balance, neither fully stable nor entirely collapsing, existing in a transitory state between life and death. The pulsations of Eridanus tell us more about its internal structure than any simple observation could. Deep within its core, helium fusion is waning, and the outer layers respond by expanding and contracting in rhythmic waves. These oscillations create dramatic shifts in brightness, making Eridanus an object of fascination for astronomers who track its periodic fluctuations. The convective cells on its surface are so vast that they could engulf entire planets, making the stars seem to boil from within. But perhaps the most intriguing aspect of Eridanus is its future transformation. As it sheds more material into space, this gas and dust will form complex molecules, carbon, oxygen, and other heavy elements, elements that will one day contribute to the birth of new planetary systems. The remnants of R. Doradus will mix with the interstellar medium, seeding the galaxy with the building blocks of future stars and planets. In a way, the death of this red giant will be the beginning of something new. Could R. Doradus be harboring something unexpected? Some red giants have been found to exhibit strange asymmetries in their mass loss, suggesting the presence of unseen companion objects, possibly even hidden exoplanets or stellar remnants influencing their final moments. While no confirmed companion has been detected near R. Doradus, the sheer complexity of its outer layers leaves room for speculation. Another mystery surrounding R. Doradus is the nature of its eventual collapse. Some models suggest that stars of this type might undergo an unstable shedding process, where mass loss occurs in dramatic, irregular bursts rather than a smooth transition. This could result in unexpected flashes of brightness, shockwaves traveling through its gaseous envelope, or even brief episodes of intense stellar wind emissions that could affect its surrounding environment. The more astronomers observe it, the more questions arise. Why does R. Doradus appear more stable in its pulsations compared to other mirror-type variables? Could its internal structure be hiding deeper instabilities that we have yet to detect? And what role does its circumstellar envelope play in shaping the final moments of its life? For now, R. Doradus remains an enigma, one of the most luminous, most studied, yet least understood stars of its kind. But one thing is certain: its fate is sealed, and one day it will fade into a glowing shell of gas, leaving behind only a whisper of the brilliant red giant that once dominated the sky. Something is lurking in the darkness of space, an object so relentless, so merciless, that even its own companion cannot escape its grasp. A celestial executioner, stripping away the very fabric of another star. This is J600-102100, a pulsar, unlike any other, locked in a slow cosmic assassination. What you are about to hear is the story of a dying star, one that is being devoured by its own monstrous partner. In the vastness of space, pulsars are often seen as celestial lighthouses, spinning rapidly while emitting beams of radiation like clockwork. But this is no ordinary pulsar. It belongs to a rare and deadly class known as Black Widow pulsars. Named after the infamous spider that consumes its mate, these pulsars are engaged in an act of slow destruction, gradually eroding their own binary companion until nothing remains. This one is a millisecond pulsar, meaning it spins hundreds of times per second, a consequence of siphoning matter from its doomed partner. The pulsar's gravity pulls in material from the companion, funneling it onto its surface and supercharging its rotation. But the real horror lies in what happens next. The intense radiation from the pulsar bombards the companion, stripping away its outer layers. This process continues relentlessly, and over time, the companion shrinks into a dense, withering husk. Scientists discovered this bizarre system using radio telescopes, where it appeared as a flickering beacon in the cosmos. The pulsar itself is a remnant of a massive star that exploded in a supernova long ago, leaving behind a neutron star. Normally, neutron stars exist in solitude, but this one found itself in a twisted relationship with another star. The two locked into orbit, forming a binary system. However, this was no ordinary companionship. It was a death sentence. As the pulsar rotates at staggering speeds, it emits beams of electromagnetic radiation so intense that it creates a force strong enough to blow away gas from the companion. This radiation bath, combined with the gravitational pull of the pulsar, leads to the companion's slow demise. Observations have shown that the mass of the companion has been steadily decreasing, suggesting that in time, it will completely evaporate, leaving only the pulsar behind. One of the most intriguing aspects of this system is the mystery of its companion. Astronomers suspect that it is a low-mass brown dwarf or even a superheated planetary remnant, meaning that it could once have been a much larger star. Over time, however, the pulsar has drained its life force, leaving behind a fraction of its original self. Some researchers even speculate that the companion could become an exotic form of a planetary object, a pulsar planet formed from the remnants of what was once a full-fledged star. But this story takes an even stranger turn. Black Widow pulsars may not just stop at consuming their partners. They may also play a role in shaping the cosmic environment around them. The radiation emitted is so powerful that it affects nearby interstellar material, possibly triggering the formation of new stars in the vicinity. The cycle of destruction could ironically lead to new creation, a paradox of cosmic proportions. This is not alone in its kind. Other Black Widow pulsars have been found across the Milky Way, but each one presents its own unique quirks. Some of them have companions that are barely holding on, emitting bursts of gas as they struggle against the intense radiation. Others may have already lost their companions entirely, wandering the galaxy as isolated ghosts, still spinning at incredible speeds with nothing left to devour. So what does the future hold for this system? If the pattern observed in other Black Widow pulsars continues, its companion will continue to shrink over the next few million years. Eventually, it may disappear completely, leaving behind only the pulsar, spinning endlessly in the vacuum of space. The victim, once a star in its own right, will be erased from existence, its atoms scattered into the cosmic void. This raises a deeper question. How many of these systems exist in the universe? If this pulsar is one of many, then how many stars have already met this fate? Could entire planets have once orbited these dying systems, only to be annihilated by their relentless radiation? The more we study these pulsars, the more we uncover the terrifying side of astrophysics. The universe is not just a place of wonder and beauty, but also a place of relentless destruction and unimaginable power. Perhaps one day, far in the future, this pulsar will slow down, its energy finally depleted. The pulsar will fade into obscurity, no longer a cosmic executioner, but a relic of a violent past. Until then, it continues its dark task, a silent killer among the stars, carrying out an act of destruction on an astronomical scale. And out there, beyond what we can see, there may be more like it, waiting, consuming, and slowly erasing the very things that once gave them life. something is haunting the depths of space, vast, glowing rings that seem to defy explanation. They appear as perfect halos in the void, stretching across millions of light years, yet no known cosmic event can fully account for their presence. They are enormous, elusive, and utterly mysterious. When astronomers first stumbled upon them, they had no idea what they were looking at. These structures were not galaxies, not remnants of supernova, not the signatures of black holes. They were something entirely different. They were named odd radio circles, a designation as eerie as their nature. But what are they? And why do they exist? The first of these structures was discovered almost by accident. In 2019, while scanning the skies with the Australian Square Kilometre Array Pathfinder, astronomers noticed something unexpected, an enormous, faint ring of radio waves hovering in deep space. At first, they thought it must be an imaging artifact, a glitch in the data. But then, more of these ghostly rings began to appear. By 2020, at least 5 had been confirmed, all sharing the same baffling characteristics. They were vast, emitting only in the radio spectrum, and seemingly unconnected to any known celestial object. Whatever they were unlike anything seen before. Each of these rings spans nearly 1 million light years, 10 times the size of the Milky Way. They are not linked to any visible galaxy at their centers, nor do they correspond to any known explosions or shockwaves. Their sheer scale suggests an immense ancient event, yet no traces of such a cataclysm remain in other wavelengths of light. No X-rays, no visible glow, only radio emissions, faint yet persistent, circling the void. One of the strangest aspects of these rings is their apparent symmetry. Nature rarely produces such perfect shapes without an underlying structure or force at work. Supernova remnants, for example, can be roughly spherical, but they fade over time and are accompanied by high energy emissions. These odd radio circles, however, appear to be stable. They are not expanding rapidly like the aftereffects of an explosion, nor are they dispersing into the surrounding medium. They simply exist, glowing faintly in the abyss, their origins unknown. One theory suggests that these rings could be the remnants of unimaginably massive shockwaves, the lingering echoes of ancient galactic collisions. If 2 supermassive black holes had merged in the distant past, their interaction might have sent out colossal energy ripples, forming these gigantic structures. But this explanation has its flaws. Such an event should have left detectable X-ray or gamma-ray signatures, none of which have been observed. Another idea posits that these circles are actually the edges of enormous spherical bubbles, expanding across billions of years. If that is the case, then what could have created them? Some astronomers speculate that they might be the fossilized remains of ancient quasars, long extinct cosmic beacons that once blazed with incredible luminosity. As these quasars faded, the remnants of their jets and outflows could have left behind these vast radio structures. But again, there is a problem. If that were true, we should see galaxies at their centers, and in most cases, we do not. A far more exotic hypothesis suggests that these rings might not be remnants at all, but rather active, ongoing processes. Could they be the signatures of unknown forms of dark matter interaction, or perhaps the effects of some yet undiscovered cosmic phenomena? If so, they might represent a new class of astrophysical objects, ones that challenge our fundamental understanding of the universe. The more astronomers study them, the stranger they become. Some of the rings exhibit structures within their halos, delicate filaments of radio emissions that seem almost woven into the vast cosmic tapestry. What could create such patterns? Could these rings be linked to magnetic fields on a galactic scale, twisting and shaping the emissions into these bizarre forms? Perhaps the most unsettling possibility is that these rings are only the beginning. If they are truly a new type of cosmic phenomenon, then they may be far more common than we realize. The only reason we have detected them now is that modern radio telescopes have finally become powerful enough to see them. If that is the case, then the universe might be filled with these ghostly structures, waiting silently in the void, unnoticed until now. What makes odd radio circles even more enigmatic is their apparent lack of movement. If they were the remnants of explosive events, we should see them expanding or dissipating over time. But instead they seem to be fixed, as though they had been imprinted onto space itself. This raises an even deeper question. Could they be relics from an earlier stage of the universe, remnants of processes that took place billions of years ago, before galaxies as we know them had even formed? There is also the question of their energy source. What is fueling these radio emissions? Unlike pulsars or active galaxies, which have clear mechanisms for producing radio waves, these rings do not seem to have any central engine. Their emissions appear diffuse, spread evenly across their vast structures. Some researchers have suggested that they could be related to cosmic rays, high-energy particles traveling through intergalactic space, but this does not fully explain their distinct shapes or their isolation. The discovery of more of these rings could provide crucial clues, but for now, their origins remain an open mystery. With each new observation, the enigma deepens. The more we learn, the less we seem to understand. And as our telescopes grow more powerful, we may uncover even stranger things lurking in the void, objects that challenge not just our knowledge of the cosmos, but our very perception of reality itself. Deep in the heart of the Abel galaxy cluster lies something that should not exist, an unfathomably large black hole, a cosmic leviathan so massive that it defies the limits of our understanding. Detected using gravitational lensing, this behemoth weighs an astonishing 30 billion times the mass of our Sun. It is the largest black hole ever recorded, a structure so immense that it shatters every theoretical boundary of black hole formation. It should not be possible for an object like this to exist. And yet, it does. For a black hole to grow to such a monstrous scale, it would have had to consume vast amounts of matter for billions of years. But here is the problem. Black holes do not have an unlimited appetite. There are natural barriers to their growth, physical laws that prevent them from endlessly devouring everything in their path. This self-regulating process, known as the Eddington limit, dictates that when a black hole pulls in too much material at once, the energy released by the infalling matter creates radiation pressure that pushes additional material away. This should halt its feeding cycle, slowing its growth significantly. And yet, this black hole has somehow bypassed these constraints, growing to a size that current astrophysical models cannot explain. So how did this cosmic anomaly come to be? One possibility is that it was born in the earliest days of the universe as a primordial black hole, a hypothetical class of black holes that could have formed from density fluctuations just moments after the Big Bang. Unlike stellar black holes, which emerge from the collapse of massive stars, primordial black holes could have formed directly from the extreme conditions of the young cosmos. If this were the case, then this object has been feeding for nearly the entire history of the universe. It would have had billions of years to accumulate mass, merging with other black holes and consuming anything that strayed too close. But even this explanation does not fully account for its size. Modern theories suggest that the formation of supermassive black holes requires a delicate balance between feeding and feedback. Too much intake, and the energy produced prevents further growth. Yet, here we have an entity that has somehow evaded this balance, growing unchecked for eons. This suggests that something else is at play, something beyond our current understanding. Could it be that some black holes do not obey the known laws of physics? Or is there an unknown process, an undiscovered mechanism, allowing these behemoths to grow far beyond what we once believed possible? Some scientists speculate that this black hole could have formed in an environment radically different from those we typically observe. Perhaps it existed in a region of space where matter was unusually dense, where gas clouds were abundant enough to fuel its continuous growth without triggering self-regulating feedback. Or maybe, in the distant past, the universe contained mechanisms that we have yet to uncover, events that allowed some black holes to grow at extraordinary rates before stabilizing into the giants we now detect. There is also another, even stranger possibility. What if this black hole is not merely a singularity at all? Some alternative theories suggest that what we perceive as supermassive black holes could, in fact, be something else entirely, exotic objects formed from unknown physics. Could these entities be remnants of collapsed higher dimensional structures? Something beyond our three-dimensional perception? If so, then their presence might hint at an entirely new layer of reality, a fundamental aspect of the universe that we have yet to grasp. The implications of such a discovery are staggering. If black holes like this can exist, then what else might be lurking in the darkness of space, beyond the reach of our instruments? How many of these impossibilities are out there, hiding in the void, waiting to be discovered? More importantly, if a single black hole can reach this size, then what does that mean for the fate of the universe itself? Could these entities continue growing indefinitely, swallowing entire galaxies, merging into superstructures that one day dominate the cosmos? There is also an unsettling question. Could black holes like this be far more common than we realize? If they are, then our understanding of galactic evolution may be deeply flawed. The presence of such a massive object suggests that our theories about the limits of black hole growth may need to be rewritten. What if black holes can bypass the Eddington limit under certain conditions? What if, instead of being restricted by their surroundings, some black holes find ways to consume matter at unprecedented rates? If that is true, then what we have detected in Abell 1201 may only be the tip of the iceberg. There could be other black holes, even larger, lurking beyond our detection capabilities. We may only be scratching the surface of what is possible. And if that is the case, then what happens when two of these giants collide? When black holes of this scale merge, the energy released would be beyond anything we have ever imagined. Could such collisions trigger new cosmic events, unleashing forces that reshape entire galaxies? Or could they create something even more mysterious? Phenomena we have yet to name. Forces that could redefine the fabric of space-time itself. Then comes the most chilling thought of all. What if we are wrong about the role of black holes in the universe? For decades, we have assumed that these objects are simply the endpoints of stellar evolution, cosmic vacuum cleaners that shape galaxies through their immense gravitational pull. But what if their role is far more active? What if supermassive black holes like this one are not just passive consumers of matter, but fundamental architects of the universe, influencing cosmic structures in ways we have yet to comprehend? If we have underestimated the power of these behemoths, then we may be missing one of the most profound truths about the cosmos. What if black holes are not just remnants of dead stars, but instead serve a much greater purpose? Some physicists have suggested that supermassive black holes could act as the seeds of new universes, points where matter and energy are funneled into dimensions beyond our perception. If that were true, then this black hole is not just the largest one ever detected. It could be something even more profound. It could be a doorway to something else, a region where our understanding of physics breaks down entirely. The discovery of this black hole forces us to confront the limits of our knowledge. It defies explanation, standing as a challenge to everything we thought we knew. But perhaps that is what makes it so important. Science advances by confronting the impossible, by seeking out anomalies that refuse to fit within established theories. And this black hole is the ultimate anomaly, a structure so massive, so mysterious, that it demands new answers. And so, we are left with more questions than we began with. How many more of these impossibilities are waiting to be uncovered? How many more secrets does the universe hold, hidden in the vastness of space? As we peer deeper into the cosmos, we may find that the greatest mysteries are not just those we have yet to solve, but those we have not even begun to imagine. The universe is a place of staggering beauty, but beneath its familiar sights lies a reality that is anything but ordinary. We have encountered celestial objects that should not exist, white dwarfs traveling at breakneck speeds, galaxies shaped by forces we do not yet understand, and massive cosmic rings appearing without explanation. We have found planets wandering alone in the void, orphaned from their stars, and stars so ancient that they challenge our understanding of time itself. And then there are the black holes, some growing beyond the limits of physics, others feeding in ways we never predicted, bending reality itself with their sheer presence. With every discovery, the boundaries of what we think we know are pushed further. The deeper we look, the more the universe resists explanation, revealing new anomalies that make us question the very laws that govern existence. Are these objects rare exceptions, or are they clues to a much larger mystery? Could they hint at forces, dimensions, or cosmic events that we have yet to comprehend? One thing is certain: the cosmos is far stranger than we ever imagined. With every new telescope, every new mission, we come closer to unlocking its secrets. And yet, for every answer we find, more questions emerge, questions that remind us that the universe is not just a place to be explored, but a puzzle waiting to be solved. Perhaps the greatest discoveries are still ahead of us, hidden in the darkness, waiting for us to find them.